Hi. So this is the final tutorial in the model to texture workflow series, and this is going to be about baked bevel trim sheets. So in the end, we're going to do something like this: texture a model that has its not has its own dedicated textures, but receive textures from a specific tile sheet or trim sheet that has been utilized for accommodating multiple geometric details across a very large board. So for example, you could texture furnitures, you could texture additional details, greeblies, you name it, using a single texture set by allocating many different possible panels and variations on these panels, like different ratios of short edge to long edge, that sort of stuff. And you create that sheet, you texture that sheet specifically, and then you UV unwrap these models in order to receive the textures from that trim sheet. So it is very similar to the classical trim sheet workflow used for level design, but this technique was apparently invented by the guys at Naughty Dog as a part of their workflow in Last of Us. And I'm going to share this link with you. You can check it out for yourself in ArtStation. So Matthew Trevelyan Jones explains the process here. And this process involves creating a trim sheet like this, with no specific geometry, as you can see. Like think about the ornate details and that architectural mesmerizing geometry that we can use for trim sheets. This one is pretty basic, it is pretty box standard, and that is by design, because after you get these multiple variations of trims, let's say, you can apply them onto a geometry, onto a very basic geometry, to create these nice looking smooth corners. That's the entire idea. And then using that model specifically, you can define different types of textures or different types of materials like wood or metal or painted wood or whatever you can think of onto the same trim sheet, and then apply this material to many different assets across the board, like a table and a window frame or whatever. Even a door could receive these textures from a single trim sheet. And you can even separate these texture channels and then use, for example, the same normal map for a specific trim, but then use different types of color maps or different types of roughness maps for creating a completely different material. Or you can even combine normal maps for those surfaces. So you get the idea. This is optimization at its finest, and it prevents the overloading of video memory by, first of all, saving on poly count, obviously, and then also, more importantly, saving on texture sizes and texture memory, or the memory which has to be allocated to texture maps. So there you go. This is the idea, and we're going to do exactly that and come up with something like this. And the idea behind it is that, let me first turn off the UV editor and its toolkit, and let me hide this final model. And let's look at what we have. So this is a trim sheet. Now mine is a bit larger than the version used by the guys at Naughty Dog. So they had even less video memory available, because obviously we are only dealing with a single material. They're dealing with literally hundreds of materials. So obviously there must be a reason why they have allocated so little space. And apparently they are creating a 512 pixel by 512 pixel texture allocated to a 1 meter by 1 meter space. I am a bit overclocking that, so to speak. So I am allocating 2048 pixels, like 2K texture, to a 2 meter by 2 meter space. But the idea is exactly the same. What I have here is bunch of faces bunch of flat looking faces with 45-degree bevels. And in order to create something like this, it's very easy. You just create a cube like so, and let's do it like 5 by 5 by 5, or let's make it bigger so you understand the basic principle. And practically speaking, I don't need any of this. I don't need any of these faces. I only need to bevel this face, and I'm gonna do that like so. Let's give it a small bevel radius just to capture that curvature, just to capture that smoothing. And you can do it with fraction, or let's turn off fraction and enter real values. And 0.5 centimeter offset might be a bit large, so let's go with something smaller like 0.3, meaning this is a 3 millimeter offset. So from this edge to this edge on the x-axis is 3 millimeters, and from this edge to this edge once again on the y-axis is 3 millimeters. And yeah, so this distance and this distance is 3 millimeters right now. That's what it means to offset as a fraction. And you can leave it like this, or you can even bevel it even further to smooth this transition right here. I sometimes like to do that, and add a bunch of segments. And this time we can do it as a fraction. It's not, super important. Something like this, and there you go. We have a nice smooth transition. And the idea behind creating this, and let's delete the rest because it is wholly unnecessary. We only need this, okay? And let me reposition the pivot to the bottom of this geometry, like so. And let's put it flat on the ground. And that's it. You can delete the history even. Now you can create variations out of this, differently sized variations, by simply punching in numbers. What I mean by that is, right now this is 10 centimeters by 10 centimeters. Imagine that I also need a version that is 10 centimeters by, let's say, 20 centimeters, right? We're going to create variations. So what you can do is grab the vertices, and this is the x positive axis. So you can type in 10 here, and it's going to grow by 10. And in this case, it is not important if you are retaining component spacing. If you're not retaining component spacing, it doesn't matter. You're just moving the entire selection by 10 centimeters on the x-axis. Just make sure that this reads relative transform. Like here, it needs to read relative transform relative to the position it is currently in. If you punch in absolute transform, it is going to go to x10 on the entire coordinate system, okay? We want relative transform. So you can create variations out of this, and I have created many of them. Like these are 2.5 centimeter chunks, these are 5 centimeter chunks, these are 10 centimeter chunks, and you can see there are many different lengths of these trims. There are also like end caps, so to speak. Imagine that I was doing a wooden texture, and the wood striations and the wood grain across the length of the tree. Obviously, the wood comes out of a tree, right? So the striations, the veins of the tree along its longitudinal axis and its cap and its cross section is different. It's going to look different as a texture. So I want to accommodate different parts which I can also use to build a different texture out of. So you get the idea. I also have large panels that I can maybe use as a table of sorts, or a stool, or a chair, or whatever you can come up with, right? The idea here is to basically create various types of geometries that then can be applied onto a surface, like so. This is the idea. We have a very basic square prism here, and imagine that you are attaching these panels, attaching these faces onto the object itself. But we're not going to do that. That's not the main purpose here. Instead, we are going to extract the normal information out of them, as we always do with the high poly, low poly process, and instead use those textures to imply that there is a corner transition, a smoothing transition between those very hard, very sharp edges. And in the end, it's going to look something like this. Okay, it's going to appear smoother, but with the added benefit of not having to create a discrete texture or indeed a high poly model for every object out there. You don't need to create high poly models for your objects if you use this technique, because you have created many different possible scenarios, many different possible faces to be applied to many different types of models. Okay, so this is the idea. So I'm going to delete these, and I'll leave it up to you to come up with your own baked bevel trims, if you, or bevel trim sheets. The baking process is later. If you want to do this, now you don't have to do it this large, obviously. I also made a smaller one, like 1 meter by 1 meter. This is perfectly acceptable as well, but it all depends on what you need. And as you can see, both of them are significantly different from what Matthew Trevelyan Jones used in his example, but I'm pretty certain that they had other trim sheets to be used across their own texturing process as well. It's quite possible that this wasn't the only pattern that they were using in the game. Obviously, this is the only one that they are showing, but there you go. You come up with your own design, and if you pay enough attention to it, you're going to be putting many different types of models in a very limited area. Okay, it's just a it's just a puzzle arrangement. You are creating a puzzle, basically. You are designing a puzzle, so to speak. So I designed a pretty big one, and it took me some time because I want to put as much as possible in here, and obviously I'm not going to use all of them in my example. Now, this is what you create for your bevel trim sheets, and then you export this. As always, once again, I also have a normal plane. In this case, it doesn't matter if it's high poly, low poly. We are not going to use high channel for this example today. So you don't need a particularly high poly version of the same thing, like so. This is not necessary. But I am going to use, obviously, a normal plane, which is a single face that I call a normal plane. It is going to capture all of these details in Substance Painter. We're going to export both of them. Okay, we're going to export both this group, all right, the bevel trim sheet group, and the normal plane, and then go into Substance Painter to create something like this. Okay, so let me start up a new file so we can start from scratch. I'm going to go with 2K resolution. We are using normal map format DirectX as always, and computing tangent space per fragment. We're not using the UV tile workflow or auto unwrapping anything, blah blah blah. You get the idea. PBR material roughness, same deal as always. Okay, and once again, I'm going to select my normal plane large. This is the 2 meter by 2 meter version. Okay, let's start. Hit OK. I can save this file, doesn't matter. Okay. Now, obviously, once again, I'm going to go to Bake Mesh Maps, and I'm going to define my high definition mesh. In this case, it is the bevel trim sheet number 2. This is the exact model exported as FBX from Maya. You know how to do that by now. So let's open it up, like so. Since this is a pretty flat geometry, you're not going to have to play around with max frontal distance, max rear distance, whatever. Okay, you can even get closer than this, but it's not going to matter much. And then we're going to capture all of these details, including height. If you don't know what height the role height plays here, you might want to check out the previous tutorial about trim sheets, but we're not going to explicitly use the height channel in this particular example. We're not going to do displacement, basically, but we need the height channel as well. So let's go to common settings and obviously turn on super sampling and make sure the output size is no less than the original size of the document. Okay, it has to be either 2K or higher. We don't need higher particularly because we're using super sampling. Okay, let's bake the selected textures, and it's going to take its time and do all of these mesh maps. So let's return to painting mode, and you can once again, as we start with the high poly, low poly process at the beginning of a texturing process, as always, it is going to appear really nice, even though the geometry here is pretty non-existent. Okay, so we don't need this layer. Instead, we're gonna create our own. Now, right out of the bat, maybe I can, introduce the height map into this thing. Now, we don't need a paint layer. Let's create a fill layer and do that. We need a fill layer and nothing but the height channel. I'm going to select in here, and as height, I'm going to define the height map itself, the baked height map. I'm talking about this one. Under mesh maps, the height, I'm going to apply this map onto the material itself, because by default, it is a mesh map. It is to be used in an operation, but by itself doesn't appear here. Okay, but the same is not true for the single channels, which are part of the material you see on the screen. The normal here, for example, is completely empty because we have no layers containing any normal information, but that is not the case for normal plus height plus mesh. This is a combination of the height channel across all the combined layers, plus the normal channels across all the combined layers, plus the mesh map itself, this normal. Okay, so this is the normal we have generated in our baked mesh map, and by combining it with the additional normal information, additional height information, so Substance Painter creates the final normal map, so to speak. And when you're exporting the textures, okay, if you go to output templates and select PBR metallic roughness, which is the default output template we have been using so far, if you go here under the normal channel, this is the normal channel, you see this. This is normal DirectX RGB. This is a converted map, and it is talking exactly about normal plus height plus the mesh map itself. It is a combined normal map. If this only carried the normal data right here, for example, as an input map, or only the normal mesh map, it wouldn't show you the whole picture. So no need to worry, but just because we want to introduce the height also, we're going to introduce it here first. So I'm going to search for height, but disable this material isolation so that I can find my original height map from the baked mesh maps, among the baked mesh maps, and plug it in here. Okay, so you can immediately see the effect. Now the effect is exaggerated, so let's see the difference. Okay, the effect is exaggerated. This is good. I want this. And always I can dial it down if necessary, and I don't even have to dial it down here after I create the normal map. After I export it, during the rendering stage, during the implementation of these texture channels, I can still dial it down if necessary, and we're going to do exactly that. So we are ready with our height, so let's go back to our material. The second thing and the third thing I want to introduce is a bunch of wood textures. Okay, so let's search for wood. Now what I can select here is, for example, this is American cherry, this is wood plane. Let's go with wood plane. Okay, and the second thing, or the third thing I'm going to get, is wood slice. So you get the idea. So slice, as you can see, is the cross section of the wooden beam. We were talking about this, so let's search for the wooden beam like so. So you get the idea. This is the cross section of the wood. Okay, as you can see the growth rings of the tree itself, or like here, and then the fibers of the tree, the strands, the veins of the tree along its other axis. So you get the idea. And I want to do it differently for different parts of this trim sheet. So I'm going to isolate this area for the slice. Okay, let me play around with the slice first. You can play around with with these values, with the grain intensity and that sort of deal. So maybe we can create more you know, denser veins so they are clumped up nicely. Always think about the original size of your models. Like this area is supposed to be 2.5 centimeters, right? So I am fitting how many striations into that area. I'm thinking about that. Also, I can dial down the wood color just a touch. All right. Maybe, yeah, less color. Okay, good. Now I'm going to put a black mask onto this thing. Okay, and obviously it's going to disappear entirely, but then also I'm going to add a paint under this mask so I can isolate this area. Now unfortunately I cannot use the polygon fill option because there are no polygons to fill here. Remember, I'm not using the trim sheet geometry. I am simply using a flat plane to capture all of those details, so the entire polygon is one big thing, okay? Or the entire thing is one big polygon. So in that case I need to paint it. I need to paint this area out, and it's relatively easy to do that. I'm going to just grab a square shape, so alpha. You can search for alpha, or let's search it from here. We can go to, you know, alphas, and under alpha I want to use a squarish shape as much as possible. So let's try to find that. Okay, so this is going to work. I mean, obviously the middle is empty, but I don't care. Hardness all the way clocked up to 1. So what I'm going to do is basically, you know, check my work as I go along. Okay. Okay. Let's fill up this area. Make sure everything is nice. Let me check the mask. Okay, something must be, you know, this area isn't that good, but we can always fix it. Let's switch this brush to negative. Okay, maybe fix it a little bit. That's nice. Okay. Okay, I have isolated that area perfectly fine. I don't like this particular area because that's where the circle ends. So I'm going to do just that. The UV projection itself, I'm going to offset it by a touch in this direction. That's nice. Okay, so I have lost those texture problems. Remember, this is a procedural texture after all, and it's not photographic texture. It's going to contain some issues. Now let's go to wood plane, and similarly let's do a few adjustments. First of all, by figuring out the color of this thing, like this color space, use custom wood color. Yes, please. So there you go. Let's try to find a color that matches. Okay, I think this works. This looks nice, close enough. That's all I care about. Okay, because the cross-section color and the face color will not be the same. They're going to slightly differ. Okay, so it's perfectly acceptable for them to look a little bit different. Okay, I'm then going to, you know, fiber colors, fiber volume intensity. Let's play around with that just a touch. But overall, I don't want this to take too long. You do whatever's necessary. Let's assume that I am happy with this. Okay, perfectly fine. And one final thing, I also want to create a dirt layer as well. So create a new fill layer. Let's call this dirt. Now I'm not going to use height channel in this thing, and I don't need metalness channel as well, the metallic channel, because this is wood. So this wood slice, even though it has metal channel, it is completely black. So is this one. Okay, this is obviously included in the original layer to differentiate it from potentially metallic layers that might exist in your layer set. But in my case, I'm not going to put any metallic details onto this thing, so I don't particularly care. And I don't even want to use a normal map here, just roughness and color. And the base color will be sort of like this dirty, grimy color, and the roughness will be a lot. Now, as you can see, even though I'm not using a normal map or a height map, I am still getting all of that normal detail from here and all of that height detail from here, which is perfectly normal. Okay, now I want to isolate this, or let's say I want to mask this off, and by masking I'm going to obviously search for, I don't know, edge, and let's release the selection isolation, and let's, for example, select dirt soft edges. This is perfectly fine. Let's put it in here, and it's going to come with its own curvature map. So let's isolate the mask by alt clicking it like so. Nice. And then let's go to curvature. I mean, this is just curvature. Do I want to use just only curvature? So fabric edges, fabric edge damage, this is acceptable. Let's go with that. I'm gonna go with just fabric edge damage and not use dirt first. I'm gonna do that, so I'm gonna call it edges and go here and just create a random lighter color to simulate the discoloration on the edges. Okay, and for roughness I can go lower. Let me check the wood plane. The wood plane roughness is wood roughness 0.35, so it's not exactly very rough, but I want this to be slightly rougher, like so. Okay, you can even check the general roughness, so it's something like this. For example, the end cap is significantly rougher, obviously. Okay, that's expected. Obviously, the end of the wood, this part here, the end grain as we call it, this is a long grain, this is end grain. End grain will be rougher, a long grain will be shinier, obviously. Okay, because this is a bunch of dimples, microscopic dimples that are capturing the light and, you know, absorbing it instead of shining it. So that's why it is significantly rougher. Okay, you get the idea. So let's go back to material. I'm going to discolor the edges slightly. Let's go back to its mask and isolate the mask. So let me play around with just a touch. Let me play around with these values a bit. Just the edges, curvature. There you go. Linear dodge. Nice. I'm gonna put in ambient occlusion by, you know, adding it just slightly, maybe. Like so. I'm adding a bit of a discoloration. And I'm also putting the texture through its spaces in order to break up all of these neat corners and edges so they appear more jagged and noisy. So let's see what the other texture does. It adds further surface detail, so I'm going to dial it down, and then we can release it from isolation, and there you go. Okay, and you can check the base color as well to see what it looks like. It looks something like this. Okay, that's nice. Okay, let's go back to material. I have slightly discolored all of these edges, and finally now I can add some dirt. Let me just type in dirt. You can even get dust dirty from here, like so. Okay, let's go back to this. Not using height, not using metalness or normal. Okay, the edges, since those edges will be scruffed, I can use height and dial it down just a touch. Okay, so that's going to make a very small difference, just a very small difference. I mean, you can see how much of a difference that makes if you crank this all the way up. So what it does basically is, collapses these edges onto itself. You're pushing the edge inwards in order to simulate that damage. But if you push it too hard like so, it is going to be incredibly chunky. So I don't want to do that. I want to just push it ever so gently. Okay, now let's go to our layer and call this dirt. Finally, let's go to its base color and make it really grimy color like so. Okay, let's go to its mask. There we go, and let's isolate the mask so we can see what's going on. Now it's very, very rough. No worries, we're gonna play around with it. And what I want to do is this edge to grab all the dirt and grime and dust, or maybe you want to do the opposite depending on the type of material you're designing. Remember, these white areas, the areas you see as white right now, when they are applied to as a texture, when they're applied to a model, they will be the edges of that model, as exemplified here. Okay, so when these areas that are right now in Substance Painter appear as crevices, okay, so these are crevices right now, when they are isolated panel by panel and applied to a model, they will appear as edges. So right now they are concave, they are turning inwards, right? But when they are applied, they will turn outwards. So what were once cavities will become edges. So you might want to think about that. So in this context, for example, dirt per this model might obviously, if this was the actual model we are trying to texture, the dirt layer would accumulate in these crevices. Obviously, it will fill up these areas, right? That's what dirt does. But if we are going to use those as not crevices, but later as outside edges, dirt will most likely not stick to those areas as it would other areas. So you might want to hold off on what you're trying to achieve with the dirt layer. Now in my example right here, I have used dirt around the edges, and let me specify, for example, if we go to standard surface and let's create a coat opacity layer. Let me show you what I mean. Like so. So I put dirt everywhere. I wasn't, specifying an area, but you can see that, dirt grabs these edges as well. Now it doesn't look stupid, or it doesn't look particularly unrealistic, but you might want to think about it. You might want to think about what you're doing, especially, for example, if you're trying to simulate paint chipping or edge damage as opposed to dirt. Okay, because dirt can go anywhere, but the edge damage will most likely grab these edges and not necessarily the crevices. But in this example, like I said, these are currently considered as crevices per the curvature map. So you might want to think about that. But let's go with the previous example. Let's try to create this one. Okay, so I'm going to play around with the curvature values just a touch. Once again, I'm not a big fan of isolating the curvature map this heavily, so I'm going to just create an exponential map like so. Okay, nice. And I'm also going to play around with the ambient occlusion. As you can see, the ambient occlusion right now, since these areas will be occluded because the geometry itself is a crevice and the ambient occlusion will be darker in these crevices, the ambient occlusion is gathering those areas, obviously. Okay, so we can crank up the ambient occlusion to capture all of that. But for example, black line all the way over here, that's not very nice. So let's try to get rid of that as much as possible. Let's try to find which part of the curvature actually takes care of that. Okay, so I think we're getting close. Okay. Okay. The ambient occlusion isn't capturing those edges, that's the problem. Mode is edges right now, we can switch it to dual, and the dual will get rid of most of our issues. Okay, and the rest of this leaky texture, we can dial it down just a touch, and also, you know, maybe not use this texture specifically, or use it even with a higher contrast to break it off, or we can, you know, scale it up, or maybe let's scale this down so it repeats a bunch of times. Okay, and then also let's dial down the curvature like so. Let's dial down ambient, maybe let's not dial down ambient occlusion. Okay, am I happy with this? I need more chipping off from the edges, from the corners, so maybe I should use a different texture too, or maybe even use texture 2 for removing, pardon me, removing data as well. Or maybe let's use grunge dirt dried for texture number 1. So we can go to these textures, so grunge map 008, I don't particularly like that, so I'm going to use dirt dried in here. So much better looking. Okay, so let's go to our texture application to remove that. Okay, not bad, could be better. Okay, I'm playing around with all of these values just to make sure that I grab all of these details as much as possible. Okay, this is getting better and better. Right, so maybe let's bring in some global blur. Much better. Okay, that's nice. So if we not isolate it as much, okay, well, let's see what it looks like. Looks something like this right now. Okay, maybe let's increase global balance like so. Okay. Looks nice. It is slightly dirty, and the other thing I'm going to do is add an effect which is going to be levels. Okay, now levels by itself isn't going to do anything, but try to imagine what levels does from Photoshop. It cranks up, or let's say it changes the representation of white values, black values, mid values. Okay, so you can, for example, squish this, and that is going to immediately change the nature of how this dirt is represented. Okay, so, or you can, you know, play around with how the gray values get closer and closer to the dark, or closer and closer to the white, so you get the idea, or vice versa, the opposite. Okay, you can even, you know, reverse it completely. This is the reversed version. Now everywhere is dirty except for the crevices. So you get the idea, you get what I mean. Now the thing is, and this is a bit going forwards, you don't have to include the dirt, you don't have to incorporate the dirt into the base texture itself. You don't have to do this. Instead, you can use this mask itself without the levels effect, okay, just the mask itself, this mask, and export it and then use it in a shader arrangement. Okay, that's entirely optional. Now the problem is, once you do this, you will also have to specify a way inside the shader itself so you can play around with the levels of this mask. Otherwise this would be meaningless. You would incorporate it into the texture itself. But the idea behind using levels is that it allows you to dynamically change where the dirt is applied on the shader surface or on the texture. Okay, so but we can do this inside Substance Painter, but once we are out of Substance Painter, we either have to merge it with the texture or export it completely individually. Okay, so let's assume that you export it individually. What happens? Enter Unreal Engine. Now in Unreal Engine, for example, I have imported the previous example, and as you can see, it is working. Okay, but this trim wood master material, for example, uses dirt, and we put that in the color channel and the roughness channel. The normal isn't affected by this, okay? But as a texture sample, I am using the mask as a texture by itself, this mask, okay? This was the previous example. And then I am putting it through a level adjustment so that if I change these values over here, I can dictate where the material is gathering dirt or where it's not gathering dirt. And simply by merging the base texture, the wood texture, through a lerp arrangement, a linear interpolation arrangement, I am blending them together. Okay, I am linearly interpolating between them, and I am using the mask itself through a levels adjustment as the control between how they are blending together. Okay, so that's what I'm doing. So let me show you what it does dynamically. So this is the material instance. If you're not very well versed in Unreal Engine and how it works in terms of material application, don't worry about it. But I'm not going to go into any details because that's for you to discover and that's for you to learn in your game engines courses. Okay, but if you already use Unity or Unreal Engine, and if you're already have a basic understanding of shader design, then you can use these techniques as well. This is just a showcase. So as a material instance, now that I am using the black, middle, and white values as exposed parameters, I can play with them, you know, to change how this material is supposed to look. Okay, I can do stuff like this. Okay. There you go. And this is also a very nice way. Imagine this inside the game engine, and imagine that these parameters are dynamically editable. You can create animations out of these types of effects. That's the power of writing shaders. Now, can you do that in Stager? Yes, you can as a coat layer, but the problem is there is no way to dynamically edit the coat opacity layer or dynamically edit anything in here. So once you introduce this alpha channel, so to speak, as your dirt, this is it. Whatever you exported as a whatever you exported as an image file, it will be you know, used as is. You cannot even go into this file itself and change some values in here like you would do in, for example, Substance Painter, or more specifically Substance Designer. But if you clicked on edit, it will throw you back to Photoshop to say, hey, if you want to edit, you edit it here. But it's not very fun, and it's not very intuitive, and it's not exactly dynamic. So there you go. Depending on the type of situation, like explained in Matthew Trevelyan Jones's example, masks and additional texture details can be exported out of these baked bevel trim sheets, and they can be further utilized in the shader process. Okay, you can use a simple wood texture, a simple metal texture, a simple whatever texture, and then put edge damage on top of it. You can put dirt on top of it, and you can do that dynamically without having to bake in all of that color information, roughness information into a specific texture. Okay, that is extremely useful, especially if you're into optimization, and especially if you're tasked with texturing hundreds of objects. Okay, so that's how people do it in the business professionally. So with that out of the way, let's assume that we are happy with the amount of dirt, and we're going to use some dirt but not too much. So let's introduce the dirt, and let's remove the isolation, and this is way too much, obviously. So first of all, let's switch this back to its original, like so, and then also dial the dirt down just a touch. Or maybe let's switch this around, and then also dial the dirt down, like so. Good. This is nice looking, very nice looking. I'm quite happy with this. Okay, so the idea here is now we are ready to use this texture as part of our master material to be applied to a different model elsewhere. Okay, so once again we export the textures. Now I'm going to not going to export the metallic channel because we don't need it. Nothing here is metallic, so you can just define 0 as your metallic layer and it will do the same thing. You don't have to export a black image. Okay, I'm not going to export height channel because this time I'm not going to use displacement, and we don't even have an emissive channel, so I'm not going to export that either. So only base color, roughness, and normal. Let me do this so you can see their names, or maybe not for some reason. And let's go to global settings, and we are using file type as based on output template. Okay, PNG, and it's going to get the bit rate like 16 bits or 8 bits, sRGB or no color mapping. This is going to depend on the type of channel. So normal and roughness are data channels. They are not getting visible information or information that is meant to be visualized or meant to be seen. They are data channels stored as color data. Okay, so these are raw, meaning that they are not gamma corrected, but the same cannot be said for base color, which is gamma corrected as sRGB. It is going to be visualized on your computer screen, that color information. That's why it is sRGB, but these are raw. Okay, and the reason why this is 8 bits because we don't need more clarity than 8-bit color data, but we need a lot of clarity, a lot of information for the normal map, because that RGB information carries the XYZ orientation of the surface normals. So we need high precision mathematical data in there. That's what 16 bits allow you to do. So global settings based on output template, based on each texture set size. That's what you do. Okay, and let's go. Let's export. Okay, let's open the output directory, and here we have the 3 layers. Okay, normal plane, large, whatever, base color information, normal map information, and roughness information. Perfect. Okay, now the reason why we're exporting these under these circumstances is that, for example, if you want to put them inside Unity or Unreal Engine, you need these explicit texture maps. Okay, but if you only want to put it inside Substance Stager, you can just send the file over from send to. Now, The other reason why we're exporting these is because now we have to reference at least one of them, whichever one is most comfortable. And in this case, I think the normal map sounds like a winner, to UV unwrap a model that they are meant to be textured by the bevel trim sheet we have just created. Okay, so in that case, I have a window over here. The window you have been seeing from the very beginning of this tutorial. Okay, I already have a version right here, but I'm going to show you how you can do it by yourself. So I'm going to duplicate this, like this is going to be a different one. So Control H to hide the original, and I'm going to grab this one and say delete UVs. Okay, and there you go. And then I'm going to go into Hypershade. So this is UV editor, but we're gonna need that as well. It can stay here. Let's open up the Hypershade. Inside Hypershade, I'm going to create a standard Maya surface shader called Lambert. Okay, Lambert 7 in this case. Okay, whatever. Material window, or let's call this wood trim. Okay, make sure there's nothing else that has been named wood trim or something. Okay. And then let's go to graph network, and as color I'm going to define a file, and in this file I'm going to select the image file, the most convenient of them. Okay, convenient in terms of being able to differentiate between all of those panels visually. Okay, because if you look at the color channel, yes, I can see the differentiation, but it's not perfectly visible. I don't want to, you know, strain my eyes. Roughness, same deal. Yeah, I can maybe differentiate between these panels, but not that much. But when you look at the normals, okay, there are clear lines that differentiate between all of these panels. So I'm going to use the normal map, but keep in mind, the reason why I'm using the normal map is not to utilize it. You cannot see the effects of the normal map if you use it this way. I'm going to use the normal map as a color channel, which is very dumb. But I'm only using it so that I can UV unwrap something onto that trim sheet. That's the reason why. Okay, so I'm going to go to Tutorials, 3D Modeling, and Model to Texture Workflow, Exports, and Textures. And maybe let's grab these and put them in here first. Okay, I'm not going to rename them. I have renamed the other ones, but I'm not going to rename them. Okay, let's go back to Maya and under for Unreal. Okay, so this is normal. Okay, so it looks something like this, and we are not using it as a normal. I mean, even the color space is switch to sRGB. It's not even, you know, utility raw, and we are not ignoring the color space file rules. Okay, so there you go. Now what I'm going to do is just select this object and then right click on my material wood trim and assign material selection. Okay, so now when I go to my UV space and turn on the image, it's gonna show me that normal map, so I can start assigning UV shells onto this thing. Another thing I have done here, and I'm going to teach you how to do it as well. Let's first of all show the UV toolkit, but then let's go to View and Grid. Did you know that UV Texture Editor, or UV Editor, has its own grid settings, similar to what it is in here, but different because this is UV space. It goes from 0 to 1, 0 to 1. These are not units, or they are dimensional information that are devoid of units. They are mathematical values, but that's about it. They are not centimeters, they are not meters, they are not inches, they are not anything, okay? But they go from 0 to 1. One range of UVs go from 0 to 1. So what I'm going to do is, first of all, reset these settings and apply and close. And let's remember that this is what we get as our UV region grid placement, okay? But if you remember our bevel trim sheet number 2, each panel has incrementally uh, different sizes, but that incrementation is 2.5 centimeters. So this is 2.5 centimeters, this is 2.5 centimeters, this is 5, this is 10. You get the idea, okay? 2.5 centimeters across a 2-meter area, 200 centimeter area. So if you divide 200 with 2.5, we're gonna get 80. So I need 80 divisions in here that I can snap to, okay? And snapping is really important in that case. So what you can do is go to grid, okay? And now let's go over everything. Now length and width is this visible area of the grid. So if I turn this into 5, this is going to clamp up to this area, 5 by 5, okay? Apply, there you go, okay? Now grid lines every 0.1 units mean that however many divisions this thing has. Now this thing goes from 0 to 1, and we need 80 divisions. So in order to find the grid lines, we might want to divide 1 with 80. So that gives us grid lines every 0.0125 units, okay? Now this is a bit too much. Instead of doing this, I'm going to divide 1 with, for example, 20, 0.05, and then further subdivide it 4 times. And also going to change the grid line colors to something more easily understood, like so. And subdivision lines are going to be lighter, so let's apply. Tile lines, it's a bit too dark, I think. That's why it doesn't like it. And also I want to see the subdivision lines as well. Apply. Okay, there we go. Much better. So now every part here is 10 centimeters, basically. Every major grid line is 10 centimeters when we are thinking about this texture specifically. Okay, so there you go. This is 10 centimeters, and every small square is 2.5 centimeters, which I can snap to. That's the entire point. Alright, so let's assume that I am happy with these grid settings. Now I want to UV unwrap this thing. Let's hide this, we don't need it. Okay, and let's delete its history, and also let's freeze the transformation while we're at it. Why not? So let's go to UV and do a planar mapping. And as always, I'm going to play around with the rotation values just a touch, so that nothing is directly facing the projection plane, so we don't force Maya to do 0 division operations. Okay, that's the idea. When we are unfolding this thing, if anything directly faces the projection plane, it is going to disappear into nothingness because of a bug in Maya's code that they still didn't fix. Okay, so let me arrange this just a touch. Okay, and then I'm going to start separating this object into various UV shells one by one. Now this is a pretty crowded scene, so I'm going to disable hardware texturing just for now and delete the history, and then I can select these edges and I want to separate them. So you might be asking the obvious question, well, how the hell are we going to separate those things? Like, what is the purpose here? Well, the purpose here is to represent reality, right? We are going with an approximation of reality. So in that case, looking at references really makes sense, because if you look, the wooden pieces here that make up this entire structure can be clearly seen as different pieces, right? This is a joint, this is a joint, this is a joint, these are joints, these are joints. There you go. Okay, so now you know how to separate this thing, or look at this reference as you're modeling your objects, so that you can create the surface topology with the intention of separating them as different UV shells later on. Okay, so I'm going to do exactly that. I'm going to, for example, I'm going to, some things are very obvious right off the bat. I'm going to separate every sharp edge, obviously. Okay, these are all going to be separated into different parts because obviously. Okay, and let's cut them. Okay, like so. Cut, and we can cut this area while we're at it. Cut. Cut this one. Right. The behind of the object is empty, so there's no reason to cut this. There's nothing to cut there. Okay, so we cut this one. Okay. Okay, we cut this one as well. And also we cut these areas. There you go. Okay. We need to cut this. And let's cut these as well. And let's cut this as well. Okay. Now, where do I want these connections to be? So I want this block here on the top to, appear as a single piece. So I'm going to cut these areas, separate it into different chunks, different UV shells. Okay, like so. And in here, for example, I want these pieces to be cut as well. Okay, and obviously I need to cut these areas too. Any sharp edge will obviously be cut, but additionally we're going to do other cuts as well. Okay, so if you were to grab everything, UV shells, all of them, and go to unfold and hit unfold, hopefully everything will be separated into managed pieces, like so. Okay, perfect. Now, another thing that we need to do is once again find the appropriate textile density for this thing, and the appropriate textile density in this case. Okay, so I have cut more than I needed apparently. These areas are apparently cut, so we want to sew them. And also find other places that need to be sewn back in. Okay, here we shall unfold again. Okay, perfect, nice. Now we have to discover the UV textile density, and once again the best way to do that is remember our trim sheet size. It was 2 meters by 2 meters, and we were allocating 2K textures onto this thing, meaning 2048 pixels. So if we were to, divide 2048 by 200 centimeters, we get a textile density of 10.24. We're going to do the same thing, 10.24 for a map size of 2048. So grab all of the UV shells and hit set. Okay, that's nice. Now the other thing we're going to do is arrange and layout, and we're going to orient them. Obviously click it a few times. Okay, and then also, since we are going to assign them to all of these trim pieces, we want to arrange them just a touch. And another thing that we might want to do is obviously, group them, stack them as much as possible. So one thing we can do is, for example, this piece, this shell, and this shell, they're all the same size. Like, apparently these edges are not separated yet. So this one we need to cut. Always check. Okay, no need for them to be connected. They are different faces after all. Okay, so let's go to UV shells once again. Let's grab these. Okay, now I can grab these, and after making sure that they are the correct textile density, I can say stack similar or stack shells. Like, I already know that they are similar, but if I say stack shells, they will be stacked perfectly on top. Now I need to find the appropriate place to assign this part on, and this looks like a winner, and I need to put it in here. Now if I subdivide this even further, since this is the middle portion of the model, or the UV shell, I can immediately snap it. But I'm going to show you a more surefire technique, which is grabbing the UVs, okay, making sure from the tool settings that the retain component spacing isn't selected, and this is different from the 3D space. Once again, just with the grid, as with the grid options, the move UV tool is a different tool than move tool. So the retain component spacing setting is individual to this one, okay? And then I'm going to snap this by hitting X on the keyboard and snapping it to the grid. Okay, let's get this out of the way. Okay, let's grab the UV, and not the vertex, UV, because if you select the vertex, it's going to select the corresponding vertices as well. As you can see, you cannot just select one vertex in here, because these vertices are represented in different UV shells. Remember, you are breaking up faces that are connected to the same vertex, so their representations as a vertex can appear on multiple UV shells, okay? But as UVs, they are separated. So in that case, don't forget to select the UVs and snap them to place. Okay, perfect. Now we can go into here and turn on hardware texturing once again, and you can observe the effects of your UV placement. Okay, and we're gonna do this for a lot of items. Okay, and for example this one, okay, perfect placement. Let's put it in here, and sometimes you have to turn on retain spacing again, component spacing, and then we can go to UVs once again, release this, and snap everything into place. This is really important. Now the middle portions, these areas are not that important, but anything else around the edges, this is particularly important, because we don't want the details of the next panel to bleed into this thing. We absolutely do not want that. And if you set up your grids correctly, then it's not going to do that, okay? It's going to work perfectly, but you have to set up your grids correctly. Okay? Okay. Here on the other hand, it's not that important. Okay. All right, so UV shell, put it in here. Okay, turns out. Okay. Turns out we don't have a panel that can accommodate this specific piece. That's a shame. So maybe we're gonna stretch it just a touch later on. Okay, we can stretch it if we want. So what we can do is just retain the component spacing, put it in here, release this. Okay, so grab the UVs. Let's do this first. Let's do that first. And while we're at it, let's do this as well. Okay, and let's put all of this like so. Just a bit of stretching isn't that a big of a deal, by the way. You can always do that. It's not a problem per se, as long as the stretching itself is not immediately visible. It's perfectly fine. So I'm going to just stretch it just a touch, and for the final touches I'm going to grab the UVs and snap them. There we go. Okay, nobody's going to be wiser. Nobody's going to realize that this part is stretched, especially if it's the bottom of the object. Okay, so grab everything once again, one by one. Oh, that's the reason why this happened, because I forgot to completely cut these areas. So that was the reason why I forgot. Happens sometimes. So what I'm going to do is grab these edges, this one and this one, and this one and this one, and cut them. And while we're at it, these edges needs to be sewn back in. So let's do that. Fine. Okay, so we can get these UV shells out of the way. Still didn't cut one part of it, apparently. Oh, we did. My bad. And now it can fit in here. So retain component spacing. There we go. Make sure these UVs are right where it's supposed to be, right where they're supposed to be. Okay. I mean, this takes time for sure, but in the end it's going to look beautiful. So this one, for example, let's find the other one, for example this, and let's rotate them both and let's stack them both. Okay, and let's put them in here and grab the UVs, snap them into place. Obviously this is easier done with low poly models because you can easily snap everything right where they're supposed to be. So grab the UV shell. Let's find an appropriate place for this one. This looks like a winner. Let's retain the component spacing, then release it. Grab the UVs, snap into place, snap into place, snap into place, and snap into place. They may look like I'm doing nothing, but believe me, I am, because ever so slightly they are not where they're supposed to be, and that small difference can mean a lot in the final texturing process. Okay, so UV shell, so these are the sides, we'll get to those later. So this part, okay, and this part, okay, and this part is here, and this part is over here, and this part is over here. So let's rotate this as well. So these parts are all the same. Let's stack them, and by retaining the component spacing, let's find them a place. Okay, nice. Let's grab the UVs. Let's snap. And snap. And snap. And snap. Good. And the top part. The front part. Any other part? Nope. Let's stack them. Find them a place. Oh, this seems like a similar place. By the way, I'm not happy with this because I've completely forgot to not retain the component spacing, and because of that reason, there you go. Okay, this is problematic. This is why we release retain component spacing, so everything falls in line. So I'm going to do that again. It's the important bit. Okay, now grab these UV shells, retain, put in place, grab the UVs, release the retain. Okay. Okay. Let's go do the other ones. So this is the shell, and this is the shell. What are these? Okay, this is different. This is different, apparently, but they have matching brothers, like so. Cool. And Same as this one. Cool. Let's make sure they are oriented nicely. They are stacked. Stacked. Okay. Let's find other parts that we can stack. So this and this. Okay. Now, here's the interesting bit. We have to talk about this. Always think about the geometry. Always think about the object that you are trying to texture. Let me just save this and delete the history while we're at it. Now, do I need, not in this part, but in this part, do I need this bevel on this edge for this face? No, I don't, because this is supposed to be a whole chunk of wood. Let me demonstrate. If you were to create a cross section of this, okay, it would look something like this. Okay, so this is a wooden piece. This is a wooden piece. Okay, and if you were beveling these corners, they will look something like this, hugely exaggerated, but they would look something like this. So this face right here, which is this face, it wouldn't have an edge over here. Okay, so think about what you're texturing and always look at references. That's the point of looking at these references, to realize that once this wooden piece is like so, these faces would contain bevels, but not necessarily in here. Okay, for this face, for this inside face of the long part, it wouldn't contain a bevel in here. Okay, so try to allocate a texture that represents that reality. In that case, for example, if this is the UV shell in question, okay, and if I'm going to find a texture space for this object, I'm not going to try to find it in here. I'm going to try to find it in here. Okay, like so. And yeah, and it's something like so. Okay. So I'm going to do this, and also let's play around with these as well. Okay, perfect. All right, now as you can see, I have created the edge here, an edge here, perfect, an edge here, but I'm not creating an edge on this side. For these pieces, I am. Okay, I am going to create faces for them. Okay, but turns out I don't have a particularly long piece that would allow me to do that, so I'm going to find the longest piece I could find, like so, and let's put it in here like this. Okay, perfect. This is acceptable. Okay, so I'm going to grab the UVs, and do something like this. Okay, is this fine? I think it is. Okay, let's try to grab these. Once again, this part does not need a bevel edge here, so I can accommodate a different part of the texture set for it, like so, but make sure it is the correct side. Right now it isn't, so I'm going to rotate this 180 degrees. Okay, and we're going to check everything in the end as well for all faces. Okay, And this one, on the other hand, it needs its own dedicated texture space. Let's grab the UVs and let's snap everything together really neatly, like so. I know it takes time, but bear with me on this. Okay. Anything else? We still have a few pieces here and there. Okay. So this one, these faces, let's put them like so. Let's grab the UVs. Okay, perfect. And once again, this wooden piece is supposed to continue along this path, so there will be no bevel here. So I'm going to put this in a slightly shorter area. Perfect. And finally these pieces. And let's stack similar. Perfect. And these will have continuation along this edge, but will have bevels on these sides. So let's determine where the edges are. So in this case, what edge is this? Or let's find it like so. For example, let's grab these UV shells and put them in here. Okay. Turns out this one has an edge over here and this one has on the other side, so let's turn this. Okay, and put it in here. Like so, for instance. So the other end does not have a bevel. So I can do that really easily. Okay, let's do the same for here. Okay, bevel here, which we don't want. And the other one also has the bevel here, which we don't want. So let's grab them, put them on a different part. Okay, there we go. Everything has been assigned. We are almost done. So let me turn on the UV editor because we don't need it anymore, and let's turn off the UV settings as well, or sorry, tool settings as well. So there we go. We have our UV unwrapped model. And check everything. Let me hit Alt 5 to remove the wireframe on shaded. Check everything. Make sure the UV map represents the correct assignment. As you can see, it is. It looks perfect, just as I wanted it. Okay, so let's export this. First of all, let's save it and then export the selection. Let me name this window 2 FBX. That's nice. Let's go to Stager and let me delete this window and let me delete the standard surface material. And from here, I'm going to select. Oh, this is the export folder for Substance Painter. So let's go over here and find window 2. Let's bring it in here. Let's import. Okay, and I'm going to put this right at the center, like so. Perfect. And this material that is currently attached to it from Maya, we don't need it. I'm going to delete it. Instead, I'm going to bring my own material, which I can do from the painter. But since I have exported these texture maps already, I can use them as well. Both is applicable. If you want to use this material from here directly without having to import, you just send to Substance 3D Stager. Okay, that's one way of doing it. The other way of doing it is that you create a new material, and from here you select base color as image, and if you look at our textures, so this was our base color, okay, like so. This is our roughness, like so, and metallicness is 0, opacity is 1, ambient occlusion is 1, okay, and as normal we are also using this. Right? Perfect. Now let's rename this to, I don't know, wood trim, and let's apply this in here, and ta-da. Now the normal map is way too excited right now, so let's make it a little bit more subtle. In this case, the normal scale can be dialed down all the way to 0.3, and you can clearly see the effects that has on the surface. It looks much nicer. Okay, camera is freaking out a bit. Okay, like so. Perfect. And that's how you do this. That's how you create a wood trim or a trim sheet specifically for texturing stuff with lots of flat faces and beveled edges, slightly smoothed edges, slightly rounded edges, and then you apply the UV unwrapping process. You do the UV unwrapping based on that bevel trim sheet. Okay, now obviously there are going to be repetitions, and the best way to doing these fixing these repetitions is simply rotating whenever possible. And what I mean by that is, if you look at the baked trim sheet here, it's going to be hard to realize that texture repetition because the normal map doesn't paint that whole picture. So we can go to hypershade now. Since we are happy with the bevel placement, we can go to hypershade, and instead of the normal utility, okay, we can go to the sRGB file, and that will showcase this texture repetition. So once again, let's open up the UV texture editor, okay, and the tool kit as well, and instead of these things, you know, having the same texture coordinates like so, if we rotate it 180 degrees, there you go. Nobody is going to be the wiser. Okay, let's make sure that these things are rotated as well to stave off basically texture repetition. Okay, some areas will obviously not matter because this repetition and this repetition nobody is going to realize. You're not going to see those two faces at the same time, but same cannot be said for this. So I'm going to rotate this 180 degrees. Okay, this thing and this thing is exactly the same, but nobody will realize that. Okay, so you get the idea. You want to create variation as much as possible with as little information as possible. That's the name of the game, with little information as possible. Okay, perfect. Now if I once again export this, export the selection to window number 2 again, let's go to Stager again, let's go to window 1 and select change the file or replace object, and once again I'm going to select classes, courses, blah 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 blah, model to texture workflow, exports, window 2. There you go. Perfect. Okay. Nice. Nice looking object. Okay. Let me show you the previous material. I think the previous material was a bit nicer. Let's change the base color to Bevel trim base color. Let's change the roughness to roughness. And by the way, this was the Maya's material once again. So there you go. And normal to Bevel trim normal. Okay, and then let's apply this. And there you go. Okay. Perfect texturing every time. Does it take time? Yes. Is it hard? Not really. Not particularly. Is it optimized? Well, it is optimized to hell. So, this is what game design is all about. I know this was a long one. Hopefully you enjoyed. And this was the end of model to texture workflow. Pick a technique, use it, and I'll see you next time.